All right. Come on. The YouTube stream looks live, but it's a black screen on my end right now. Do I need to refresh my end? Am I logged into the right account? Okay, yeah, I am. Okay, here we go. We're live. Let's go. Person just said thanks. All right, let's look for a new question. Help with a differential equation. Okay. Ooh. This is an application of differential equation I haven't seen before. This is exciting. Clinic has 20 beds. Patients stay an average of 6 months. Patients come in for assessment. 20% are admitted. How many patients need to come in for assessment per month for the clinic to stay full? Ooh. The clinic has... Wow, this is going to take some actual thinking, which I'm not good at. So the golden rule with these, it's that you always have your overall rate is equal to rate in minus rate out. I'm just using this text box for notes here. I don't know if I'm going to reply to this question yet if I don't feel confident. So we want to do rate in minus rate out. So our rate in is going to be there's a distinction here because they use the word patient in two different contexts. Or like, I feel like patient has two different definitions here. It might be better if we have two different words, because patients say an average of 6 months, implying they've already been admitted. But then it goes on to say, of the patients who come in for assessment, 20% are admitted. So or maybe it's fine to use the same word. But if like our rate in is, say, 0.2 times p, so are we modeling? Yeah, we're modeling the number of patients, and then at the end we're going to worry about the bed count. We don't worry about the bed count for now. And then the rate out patients stay an average of 6 months. So are we doing number of patients divided by 6? Because we want things in per month. If patients are coming in continuously, can you say that you lose a sixth of each patient of your patient count every month? That feels like it makes sense. But that means isn't this going to be too simple? Because if you just have 0.2 times p minus, I'm mixing my decimals and fractions, I guess. 1/6 times p That just feels too simple, doesn't it? So I kind of like this voice person thing with population problem. I kind of look at population problem, how that gets set up, and see if we can engineer it to match this patient problem. Hey, Jed. You trader? What? I thought I'd try it. What's wrong with that? I do like streaming the math category, but I never streamed the science and technology category. I'm like, oh, maybe we'll get some new faces to come in. I mean, way back, I used to stream in just chatting. Time to do some physics. I mean, this problem that I'm trying to work through is pretty applied, I guess. I was about to call it like biology, but like it's not really. It's based on the population problem, which is biology, you know? Mm. Yeah, I really don't feel confident. Like, I feel like it might just be as simple as this, but I don't feel confident. Actually, no, there's no way. These P's cannot be the same. This is, yeah, I'm definitely wrong. Like, it's 0.2% of the people coming in to, like, coming in the front door, and this is a sixth of the people who were admitted. So you could do 1/6 times 0.2 times P, maybe, if you want to say patients is anyone who walks in the door. But it also means, like, I don't think that's right, because you're going to be filling up really quick, which maybe that is accurate, depending on the hospital. I don't know, it's a fun problem to see the solution of. I don't feel confident answering it in a vacuum, though. Oh my god. They give angle measures with degrees. It's like arc minute and arc second or some crap with the apostrophes. 44 student survey, 25 say they smoke cigarettes. $25 over 144. Hey, ZZZ. Whenever someone says hi, Brody, they say hi to me, either they like it or not. Yeah, even if your worst enemy says it, they're still saying hi to you. Puppers, thanks for the follow. What's the midpoint of these two values? Trying to dissect what this person is actually asking. Oh yeah, I just saw you in Zach's chat, and I think I saw you in Dan's chat like last night, if I remember right. Either way, I'm glad you found us, and welcome in. If you have any questions for me, please let me know, because I'm also happy to help. But I'm always glad to have another person who is aware of Twitch as a resource. Sorry, I just turned my heater on. It's kicking a bunch of dust in the air. I finally broke down. In February, I started turning my heater on just for like the coldest days. Yeah, sure. All right, so I think I know enough to answer this person's question. Most classes you took have master's students on them, some have PhD students. Are they going to suffer too much or they're going to suffer too little? Zach, thank you very much. Welcome in, everyone. SPQ, hey. You're like intro math, you skipped a lot of grade 11 or 12 and it's betting you in the for university. Oh yeah. That's a very common story, Puppers. Like students just like skating by through like math in grades 11 and 12, and then they come to want to study a hard science and have to like calculus or linear algebra or something, and then you really need the stuff. Then they wish they paid attention, but before science and technology 3 times the homework this week. Nah, I just figured I should try this category. I never actually streamed in it, and it does get much more traffic than math. It is my assumption, so I was like, oh, let's at least try it for at least one stream. I might do it for the week, just see if I get any like new faces coming through. Oh, and Brian Hyatt. I hope I'm not missing anyone. Oh yeah, and then ZZ over on YouTube. I feel like normally when there's grad students mixed in with undergrads in a class, like the grad students have their own like extra section or extra like homework. So like they don't expect you to do the grad school level stuff, I hope, yet. I'm stream for 14 consecutive days and move to the Fortnite category. Did someone do that? Oh, I get it. 14 days in Fortnite. Nah, I mean, streaming in the big categories is like probably one of the worst things that you can do unless you're a pro. As far as I've heard, like if you're streaming like League of Legends or Apex Legends or one of those with like a bunch of viewers, people really have no reason to watch a random person. Although I get the joke though. Oh, Maxie, it's good to see you around again. It's been a minute. Hope that you've been good. Chatting at 600K viewers. Yeah, that's like, say I originally started streaming in just chatting when I first started, and I was like, ooh, I see there's a math category, but it's probably not intended actually for math. But then it's like, man, just chatting is so freaking congested that I'll just do it, and if Twitch tells me to stop, then I'll stop. But until then, I'm gonna try it. One professor is gonna grade them differently. I guess they might. I would hope so. To Legends, then you'll have a league of them. Oh god. Oh wait, maybe when they say check this claim, I think they mean that claim. Okay, never mind. Okay. So yeah, that's a rule if you're going to use a confidence interval to act like a p-test, because they're really the same thing. I look at whether your sample value is within the bounds of the interval. College engineering, I probably can't do it. I'm just kind of curious to see what's up with it, though. Just do it philosophy here in the department, so uncommon people first term or so to take grad courses. I mean, it is cool to have the opportunity. I hope it wouldn't be like forced on you, though. You ask questions in class saying I don't understand the whole concept. Oh yeah, that's I can definitely empathize with that, puppers. Yeah, whatever this is, it looks complicated. So let's not look at it. Put in homework up? Oh, sounds good. Simple graphing, you just get flustered looking at the questions. Oh, I mean, I get that. Just knowing how to start is often the hardest part. Yeah, so how it's always gone for me is like you show me how to do the problem once, twice, or maybe a few times, and then I have to grind it out a bunch like for myself on my own, and then it starts to sink in once I do like grind that type of problem. So so our function is x squared plus 2, our interval is -3, 3. We're going to pick 5 points on the x-axis, find the function value at those points. Keep in mind that the points on the graph of the function are the form x f of x. It's kind of a weird hint to put in, but it's not wrong. All right, so let's, how am I going to fit this on the screen? Oops, I didn't mean to do that, but it's actually fine. I'm just not going to use the left part of my whiteboard. How about that? No, that's too small to be useful, right? Let's just, I'm just going to not show the question. Sorry. Okay. Okay. So we have f of x equals x squared. Was it plus 3? Plus 2? Plus 2. The interval -3, 3. So for part A, we want to pick 5 points on the x-axis. Yay, whiteboard, hell yeah. So for part A, 5 points on the x analysis. So the important thing to remember is that this interval basically refers to our x-axis. This is what values for x we're allowed to plug in. So anything between -3 and 3, including those two numbers, is fair game to plug in for x. So for part A, where we basically they're asking for points that you can plug in for x, so we can choose any 5 between those two numbers. You could choose some weird ones like, 1/3 or e if you want to go irrational, but let's just keep our lives simple and say maybe -2, -1, 0, 1, and 2. I think those are kind of like, I'm trying to go for lowest whole numbers, or integers is a better word. So I just kind of like went in the middle there. Find the function value, add those points. Who's that over on YouTube? Manashi Saha, hey, welcome in. Now we need to find the value of f of x at these points, so I'll make it into a little chart. So our x values, I use the same ones as up here. F of x, we just plug these in for x. So -2 squared is +4. +4 plus 2 is 6. Plugging in -1. -1 squared is +1. +1 plus 2 is 3. Now we have 0. 0 squared is 0. 0 plus 2 is 2. Now we have 1. 1 squared is 1. 1 plus 2 is 3. Then 2. 2 squared is 4. 4 plus 2 is 6. And with a parabola, you always expect -1 and +1 to have the same values because, well, I shouldn't say that in general, right? No, I shouldn't say that in general. Just for this parabola in particular, we happen to get this like symmetry, but yeah, I wouldn't say that as a general rule. It depends on the parabola. So never mind what I just said. Christopher Lamont over on YouTube too. Can you help with this question? Deduction show any natural number. Can be written as a sum of n distinct fractions of the form 1 over k, where k is maybe, Christopher? I'll have to think about that more after I get through this question. And Manashi, sure, if you want to type that question out. Peppers, yes, exactly. So I could have said that more explicitly, but when I did that -2, I took that formula and I plugged in -2 for x everywhere. So f of -2 is -2 squared plus 2. -2 squared is +4 plus 2 is 6. So I did this exact procedure for all 5 of these points here. I hope that makes sense. Can I not write? You just rewrite that entire part. Don't worry about it, you got it? All right. Christopher, sounds good. If you run into anything else, let me know. Okay, sick. Awesome. Glad you're with me so far. Keeping in mind the points of the function of the form x f of x, use work from B to obtain 5 points on the graph of f of x. So I don't know how to interpret part C. I guess we would say, because part C seems to be kind of asking the same question as part B. Maybe they just want it written in a different format, which is, they're saying like they want the points in terms of x comma f of x. So I think we're going to take each of these as points and just write them in a different format is the best that I can figure. Well, part D is to actually plot it. So this is the wording of the question. Part C, I guess we just write them as points. Seems too easy. Yeah, this one is throwing me off a bit. Oh, so part C and D both have to do with the graph? I guess that's fair enough. Okay. Yeah, so let's draw this graph. Actually, how far out does the graph? It's fine. So okay, I'll say like the first way I was interpreting part C is that you should take these and write them as points. So -2, 6, -1, 3. I thought you just have to do that like down the entire chart, which maybe that is what your teacher intended, but I think what Maxie's saying is more likely to be true, which is part C is actually asking you to work on the graph and to plot like these points, but you don't necessarily have to write it out. Okay, so going over to the graph here, we notice all our y values here are positive, so I'm going to worry more about the positive y-axis. X, y. X's will go from -3 to +3, because that's the interval that we were given. I think the graph that you provided is slightly, it goes like a bit farther out, but that's fine. We just don't have to worry about, actually we can even go out to 4 just for fun. We won't need it though. Our y's, they go up to 6, so let's go at least 6 up. 1, 2, 3, 4, 5, 6. I could say 7, 2 just for fun. Okay, so with the parabola, I don't care if I'll start from 0 just because 0 is a nice number, so let's go 0, 2. Then 1, 3. Right 1, up 3. 2, 6. Over 2, up 6. And then -1, 3, left 1, up 3. -2, 6 is left 2, up 6. So I think that's what they want for part C, just those points drawn in, and you don't connect them quite yet. That's part D. So I hope you're okay with that so far. So yeah, and then for part D, I do what I'm about to do in red here, which is actually connecting the points. Oh wait, not arrows. There's a bit of a distinction here. We're restricted to -3, 3. So actually, it would have been better if I chose slightly different points here. This parabola does not go on forever because of this restriction. So I'm just going to quickly add on 2 extra points, which are 3 and -3. If you plug in 3 here, it's 11, because 3 squared is 9, 9 plus 2 is 11. And I'm going to squeeze in -3 is also positive 11. That's important because of what I'm about to show you. So I went up to 7, 8, 9, 10, 11. So our graph is actually going to go out to +3 and end at y = 11, -3 and also end at y = 11. I'll connect those as well. So I might chop off like, maybe the 2 and -2 in your work if you just want to keep it to exactly 5, but the problem's going to go out to those points and just end. No arrows here because of that -3 to 3 restriction. You might have been taught about closed dots and open dots. These are definitely closed dots. I kind of already drew it, but a closed dot means that the endpoints are included, and we know that they're included because these are square brackets. If we're given a different problem, these are open brackets or parentheses, it means those 2 points are not included, and you would make like circles there instead of like filled in dots. But since we have the square brackets, we don't have that. You haven't been taught that, I wouldn't worry about it, but just that often does get taught. So I'll make sure that if you do have to worry about that, then you know what's up. All right, so let me know if you have any questions about that, Peppers. Hey, Jackson. You weren't taught like graphing parabolas, Rowdy? Dang. I'm doing good. How about you, Jackson? You remember that? You asked about the wording of C. You think that's perfect? Okay, awesome. If you have any more questions, keep them coming. I see Minashi over on YouTube asked a question, so I'll look at that first. Get used to multiplying two negative numbers, flip the signs. Oh, yeah. Good, you get your math results soon, so should be an A, but never know. Oh, well, hopefully it is. No worries, puppers. Thank you for the question. Maybe you know any math you were taught was when in one ear, out the other. Fair enough. All right, so Minashi is saying the equations of two equal sides of an isosceles triangle are 7x minus y plus 3 equals 0, and x... Oh shoot, Minashi, I think your question got cut off. That's all that I have so far. I copied it over to Twitch chat in case they want to see it. Equations of two equal sides of an isosceles triangle. Third side passes through the point. Oh, or is the question to find the equation for the third side? Huh. That's kind of interesting. How would we do this? It's like a coordinate geometry thing. There might be a trick that I don't know. Yeah, so we definitely graph both of these lines. Draw it. Yeah, I'm hoping that we get things that'll work out nicely to do calculations with. Because honestly, I would do this like with vectors to figure out the angle between the two. But I don't know if Minashi is supposed to do it like that. All right. So let's draw as Maxi was suggesting. We have, well, let me copy on the equations first. 7x minus y plus 3 equals 0. Given in standard form, which I guess we can use. X plus y minus 3 equals 0. Okay. Actually, standard form would have these on the other side. I don't know. That's fine. Either way, it's given in this form so we can use the intercepts to figure things out. It's going to be color coordinate things. Okay, so starting with the blue one, if y equals 0, x equals negative 3 over 7. So we have a point there. If x equals 0, y equals positive 3. Oh, that's... Who the heck drew that line? Not me. I can't even connect the dots, dude. There we go. Then for the red one, if x equals 0, y equals 3. Ah, okay. And then if y equals 0, x equals 3. Oh, wait. That angle seems weird. The third side passes through the point 1, negative 10. Four, 5, 6, 7, 8, 9, 10. Huh. I'm sure it's possible to make an isosceles triangle out of this. I don't know how. So these are the two sides that have to be equal. And we have to name a bottom line that makes this thing isosceles. How can we do that? Meanwhile, things like the distance equation, but that seems like it could get really tedious. Yeah, Jed, please. Draw a line between the intersection of the two sides and the third point. Create a perpendicular to that line through the point. Oh! You're right. I like that. I can't connect the dots. Okay, this is a straight line. Don't worry. So yeah, Jed, you're saying to make this line, because we have 2 points, so we can figure out the equation for that line, and then take the perpendicular of that, because in any isosceles triangle, well, the angle does bisect. We don't know that that bisects. I don't know. You're not right this time. Yeah. I like the idea that the angle bisector makes that right angle, but you're right. We could have like that or something, which makes that technique not work. That'd still be a helpful line to have between those two. Could it be that there's infinitely many isosceles triangles that you can make with this? Well, of course there's infinite, but I guess with different angles. No. No, all the lines should have the same slope. Can we figure out what the slope of this must be? I keep wanting to use vectors. To like, I want to do the dot product to figure out the angle between those two. And then you could figure out what the remaining angles must be, and then somehow translate that angle back into a slope. If you convert it into radians, I guess. Measure an equal distance on each of the two known sides. Figure out the slope between those 2 points. Ooh! How can we work that out? I love that idea, but how do we... So if we just arbitrarily take the length from here to here, and then we project that line out, so it's just like that's an easy length to compute. 3 squared plus 3 squared, square root it is 2 root 3? Quick math? No, it's 3 root 2. Okay. So then, if we start from this point and go 3 root 2 distance along that line, how do you figure out that? You need some kind of like difference from this. Some common point, whole number, distance. I mean, you could do that too. You could just like take a distance of 1 or something as well. And try to calculate for each line. Okay, I think I know how we can do it for that line the way that's seen though. If we want the distance of 3√2, we can use a distance equation. This might be needlessly complicated. X squared plus y squared, and we know that y is equal to the equation, well, we could solve that for y. Hopefully that's not horrible. It might be horrible. I have a feeling that it might be horrible because I arbitrarily chose something random. If that factors well, then I'm buying a lottery ticket. I'm giving that to Wolfram Alpha. That'll be the x coordinate. With what I did, but it might be easier to do what Jed is saying and just take your distance like 1 or some kind of simpler thing, which I'm probably about to do that when I see that the roots of this parabola are horrifying. Yeah, well, let's not have roots like that. Let's just try distance of 1. I mean, that's kind of ugly too, but 7x plus 3 is also just like a bit of an awkward line to work with. GeoGebra? This would be like a pretty good thing for GeoGebra, I think. Oh, that's not it. Let me keep trying this and just see what we get though first. You get imaginary? No, that can't be right. I'm not even doing this right. No, I'm not doing my distance formula right, I don't think. Hey, White. Yeah, no, it's because I messed up my distance formula somehow. This is a problem I was asked by Manashi over on YouTube. It's a little challenging though. I'm gonna cheat and look at Jed's GeoGebra. I just pasted the question again. Oh, so use the circle to figure out an equal distance on each of these two lines. You drew the line connecting those intersection points to figure out the slope. Oh, sure.
If not, that's fine too. Can you hear me okay?
Yes. How is this mic in Discord? Is it still cutting out?
It's harsh, but it's fine.
I'll switch to my other one.
You good?
Okay, you should be able to hear me
Yeah.
better now.
That's normal. Okay. Yeah, so I plotted the two lines that you gave me. If you look at the algebra, equation 1 and 2 are the ones you gave, and then the third point. So then
Right.
I just created a random point on line 2, and then I created a circle with radius, from the intersection to that point. That gives me the intersection of the line 1 to give me that isosceles triangle. Connected those 2 points B and E together, and then created a parallel that ran through A.
Okay.
And then that equation at G basically is the equation of that line that runs through A. That's
Yeah.
parallel to the line F, which is the
Yeah, it's nice to see it actually like graphed out like
so it is
this.
a very clean solution. I mean, I think that if you multiply that bottom line by 3 and move everything to the same side, you get x minus 3, y minus 31.
Yeah, there's gotta be some way to do this algebraically. Like I'm just missing the trick. I might try to Google, see what it is. I'm sure there's some kind of formula or something. I'm not sure though.
Yeah, it's kind of cool when you learn to use tools like this and you can actually kick something out like that. I mean, that was, I think I mentioned, hey, why don't we use GeoGebra? And then like 2 minutes later, here's your link.
Yeah.
Yeah, I think I didn't start the GeoGebra until after that. Can you not find some common point, whole number, distance? I didn't put any measurements on that graph to see kind of what can we get one that has a pretty distance.
About to do the worst like Google search I've ever done, but
Especially if you're trying to snap this thing to a grid and get like a nice clean, like snap it to different values, trying to find one that has something in common.
oh yeah.
Yeah, that's perpendiculars. Yeah.
I think perpendicular would be too easy. This one I just found I think is a similar. This person I think this uses vectors.
Well, find the angle between them. That's
Cause I was thinking like yeah, you do need to find the angle between them.
if you could find that angle between them, then you could bisect that angle, because an isosceles triangle, when you take the vertex and bisect it, you get a perpendicular to the third side.
Right. I mean, you might not
So
even need to bisect it. You can just what the other two angles must be if you know what that top angle is. So you can do like 180 minus that top angle divided by 2, and then we can work out the slope of the line from that.
Well, the purpose would be to get if you can get the slope of that third side as being, perpendicular to the angle bisector, then you've got a point that you can plug into the y equals mx plus b formula
Oh,
to
I
figure out
see. Okay.
what the y-intercept would be. So if
That's
in
fair
this
too, yeah.
case, your perpendicular would be what, 1/3, and then your slope of your perpendicular would be negative 1, is it negative 1/3 or something like that, and then when you what's my excuse me, line is, okay, so it's y equals 0.3x, so the perpendicular would have to be 3, -3, right? So then or the bisector would have a slope of -3, and so the perpendicular would be positive 1/3.
Mm,
Does that sound correct?
wait, you're
So
getting like the bisect to one of the original lines? We'd have to do the.
if you bisected the angle BCE,
Oh, right, yeah.
then you're going to get, so if you look back at that GeoGebra link, I don't know I think it updates automatically if I draw on it again. I just drew an angle
Let's see.
bisector for that.
Oh no. Oh.
Here, I'm saving it. So just do a refresh. There it goes. Nope. It's the same link. If you just refresh the page, you should get the new bisector in there.
Got it.
Okay, so that bisector, if you look, is h, and you can see the equation for that's y equals -3x plus 3. So the perpendicular, so line F would have to have a slope which is the negative inverse of the perpendicular of the height slope, right? So -3 becomes positive 1/3. Right?
Yeah. How are we getting the equation of the perpendicular or of the angle bisector line though?
Yeah, that's the next question. It's like if you can figure out the angle, then you can bisect that angle and get what the intercept is, and what the if you can get the bisector. I'm not sure what the equation is to get the slope of that, but the y-intercept is 3 because that's where they both intercept.
Oh, I bet it's the average of the two slopes. I couldn't like prove that.
What's the oh?
But like that just kind of makes sense to me if it's the average.
What were the two slopes? The first slope was -7. Oh, no,
it's
7.
Positive 7 and 1. -1.
-1. And no, it's not the average because this slope is 3, right? -3. Is that the average? Yeah, that is the average. You're right.
No, it should be
because 1
7. Oh yeah, it is the average. Oh,
1 would go down to -3, or 7 would go to negative.
That's like completely by feeling,
it's
but
not. Is it the average or is it the 7 and -1?
Because 7 plus -1 is 6, divided by 2 is 3.
It's going to be a slope that's. It's not the average. It's the
average and midpoint are the same thing.
7 and -1. Yeah, okay. Well, the 7 and -1 would be 6, and then divide by 2, you get 3. But it's not that; it's -3.
Oh.
Right.
Oh, that's annoying. You couldn't know to flip it, but yeah, I'm really
-1.
reverse engineering it.
And so the slope becomes a -3 instead of a +3. I mean, it is going to be a point equidistant from all of them, right? So, what was what was the x-intercept on the two lines? One was, one of the lines was x-intercepting at 3, right?
Yeah, the other one was
and the other one
3
was
over 7. -3 over 7. You're right.
So what's okay? And you can't really take the halfway point on that either, can you? Because that's not the x-axis isn't.
No, it's not like a.
Yeah.
Yeah.
I mean, if you can get the slope of that bisector, what is there an equation to figure out the slope of the bisector of two segments?
I feel like I could do it using like trig and then just like some logic with like figuring out the slope of one of the lines and adding on the angle of the bisector.
Angle bisector theorem.
But I think there should be a formula. Oh, hey, William Arne over on YouTube and Crafty on YouTube.
There you go. Equation of an angle bisector given the equation of two lines.
Marcus, thanks for the kind wording. Give me these X. Hey.
The angle bisector line is.
So Crafty, that should be a quick one.
The coefficients of the x plus the coefficients of the y.
I believe that's arctangent.
Is equal to the sum,
Let me
sum of
verify
the
that,
coefficients
though.
of the x plus the sum of the coefficients of the y is the sum of the constants. So if we add those two equations together,
yeah,
which
Crafty, the answer is
arctan. Got a 1 and a -1, so we're going to get
plus
something
C.
really weird, right?
And William, I can solve that on the board in a second here. Sorry, I said to the people who come into the YouTube chat with different questions. I'm not. I'm not sure. I feel like I want to read through this like stack exchange thing or something because I think you and I could invent some way to do it, but there's going to be an easier way.
I'm gonna look into that and see if I can figure out a way to get that. Because if you can get that, then you've got the slope of the base, and then you just need to find the y-intercept to get the right base for that triangle that goes through that point, which would be easily calculable by just plugging in that point into. So once you get that slope of what was it, 1/3, then you can plug that point 1, -10 into the y = mx + b equation to figure out the y-intercept.
Here, I'm sorry. There's one question I want to like go and do quick. Wait, I don't know if my push to talk was working there. There's a question on YouTube that I want to like do quick, and then can I come back to this one if you don't mind?
Yeah, absolutely. Do you mean to hop out, or are you good? Just hang out quiet.
It's fine. Yeah, we can stay here. It's just like a single variable solving for xing, so it should only just be a second. Okay, so William, let me work out yours just because it's quick. So I want to like get to it. We have 8 minus 2x equals -7 minus 5x. Right? Okay. So yeah, if you're just solving this for x, William, I'd say we want to get all the x's on one side and get all the not x's onto their own side. So I'm going to start by getting this 2x over to the 5x. So let's add 2x to each side. 8 stays as 8, minus 2x plus 2x is 0, so we just get that on that side. The -7 stays the same. Now negative 5x plus 2x is negative 3x, so minus 3x. Now let's get the not x's to their own side, so I'll do +7 on each side. 8 plus 7 is 15. -7 plus 7 is 0, so we just have a minus 3x over here. Now there's only one step. Now I've gotten everything onto their own side. We just have to divide by whatever's in front of the x. We have a -3, so let's divide each side by -3. So 15 divided by 3 is 5, and we have a negative sign, so just stick a negative sign in front. You get x equals -5. And if you're ever not sure, you can always take this last answer, -5, and plug it back in up here, and you should get a true statement. So just like show the little like verification thing. So there's an x here, so let's put our -5 answer in here. There's an x there, so put -5 there. So 8 minus 2 times -5 is +10. So 8 plus 10 is 18. -7. -5 times -5 is +25. -7 plus 25 is +18. So it checks out. Just a nice little way that you can like verify your answer if you're ever. Okay. Oh, Jed, I think there's an easier way. Oh, you might not be here. This looks
I'm still
so
here.
much.
I just muted myself so I wouldn't talk over you.
Oh, okay. No worries. The person just took the. I mean, I'm sorry if you were saying this and I just didn't hear, but the stack exchange side is just saying to set up the equation for a line passing through that point, and then you can intersect it with the two lines that you're given, and then you have two equations and two unknowns. It's this thing that I'm looking at here. I think it's the easiest way to do this.
I found the equation for the bisector. It's not pretty.
Oh, really? Okay.
Yeah, I'm checking it out right now just to see if it actually works out.
Does this work? Wait, there's infinite many lines that go through that point in the two other lines. As a function of m. So it's not that simple, okay.
No, it works. Okay, so the you ready for this?
Okay, yeah.
This is gonna be ugly. Hang on just a second. I'll send you another link here,
Okay.
or I'll send you something in the Discord. I think is probably what I'll end up doing. Here's what I found. I'll put it in chat for everybody's benefit there. It's nasty. You take the first equation and divide it by the square root of the sum of the a and b coefficients squared, or the
Oh,
sum of the
this is
square of the a and b coefficients.
the distance from
Yeah,
the point to a line.
right. And then you set that equal to the second equation, same thing. And so I did a little math check, if you will. I'll just go ahead and share that out real quick. Share the math check. There you go. So you can kind of see the work there.
I think this ends. Yeah, this might actually end up being the thing that I was just reading on Stack Exchange, but they just explained it more intuitively than like giving this formula here that just does it for you. Did you send something else?
I started sharing my screen so you can see.
Oh, let me bring that up. All right.
So
I
the
got
two
you.
equations at the top, and then this equation basically takes the first equation, and then you take the square root of the sum of the squares of the two coefficients, so 7 and -1, and then the second equation and the sum of the coefficients for the x and y again. So you end up reducing, simplifying, cancel out the square roots of 2, move the 5 across, and it's plus or minus over here, but we're going with this right now. And then bring the 5 across, multiply it out, simplify, and you get the equation of 1/3 x plus 3 as the bisector. Is that correct? Is that what we got for the...
Oh wait, we said that it's not necessarily the midpoint.
No, but that's the bisect. That's the equation of the bisector of that angle.
Oh yeah, that's right. That's right.
Actually, no, that's not right, because it should have been y equals -3x. So where did my math mess up? I should pull the 6y over here to begin with, but I messed up something on that formula. I didn't do plus or minus, because this should have been a 3x plus 3 according to the GeoGebra work we did earlier. Bring that into here as well. This equation, the equation of this line right here, is -3x plus 3. Here.
Actually, you did find the perpendicular of that. Because
Well,
1/3 is the flip.
This is not the
negative.
correct equation of that line.
I think
my point. It's like,
or yeah, this can't be right. I mean, or is this like just cut to the end result?
5 squared to 2, yeah.
So I thought this equation would just directly get you the bottom line.
Well, it gives you this equation gets you the bisector of. It's supposed to give you the. Sorry, wrong article. I've got 3 things going here. Let me bring
I just put right up on my end.
Well, I was just bringing it up on my screen as well. Prove that the equation of the bisectors of the angles between these two lines are given by this.
Oh,
so
okay.
That's the equation I filled in. And I did not get the bisector equation. So I was looking to see if that's the... Yes, that's the equation.
Maybe go back to your work? The plus or minus part is kind of weird.
Yeah, so this should be a plus or minus right here, right?
I don't know how you're supposed to... Maybe you're supposed to just make the call, like, on your own which one you take, like, visually.
doesn't like the PM. That's right. There you go. Stick that in here. But even then, okay, so if I do that and that, then this could be completely the wrong side. These should all be swapped around to the other side, right?
Potentially. That's so weird to me though.
So let's consider the case where,
because we do expect a negative slope, so I guess we would want to flip those signs.
Do these negative and then plus 15, right? Can't do math here. So if we bring this, the x's over, we get 12x. We bring the y over, we bring the constant over, we get negative 12, and then we bring the y over, we get a negative 4, right? Divide all by 4, we get 3x minus 3 equals 4, or negative
equals y.
And is that the slope we were equals y? Yeah.
I think that was the equation, right?
Was it negative 3?
Yeah.
Yeah, negative 3x plus 3. So there we go. So okay, yeah. So it's the negative of this, right? So this is the positive, and this is the negative of it. I don't know how you know which one you're supposed to choose.
So it is the average of the slopes, but you just have to arbitrarily choose the plus or the minus, I guess, visually. Actually, I wonder if that article explains it.
This article here?
Yeah.
They do a proof of it in multiple parts.
But like, do they talk about the plus or minus part specifically?
So here they put the plus or minus. Let's assume where the
oh,
same
because
symbols.
There's two bisectors. One goes with one and one goes with the other.
Yeah, that makes sense. So you just got to know which one's which.
They're perpendicular to each other. Okay.
Yeah.
So yeah, you do have to just visually know which bisector you want.
Okay. That's a good call. There are two bisectors. So. Yeah, so you get that equation, and now you've got the slope of negative 3, so you know that the perpendicular that's going to have a slope of 1/3, and you're going to plug in the point from the original equation. So if you have y equals mx plus b, and you plug in the original point, which was negative 10 equals 1/3 x plus b, and x was negative 1. Is that correct?
Yeah.
No.
Oh wait, it was
1.
positive 1, negative 10. Yeah.
Okay, so yeah, so they solve that, and so you get, bring 1/3. That doesn't. Yeah, so you bring the negative 1/3 over, so you get negative 31/3. Right.
I think and I think that was right.
31 over not that equals b. So then your final equation equals 1/3 x minus. That.
Oh, this is basically LaTeX. It just translates it into the actual thing for you automatically. But like the slash
it doesn't
frac
copy
is the same.
paste into LaTeX correctly. But
okay.
I've gotten used to this format, so because it looks clean. And I can't be bothered to learn all the LaTeX stuff.
You basically have learned those, like the slash frac and all that. It's basically that.
It just doesn't copy and paste quite right. So you end up with that equation, which is, I believe, what the solution was, right?
Yeah, I think it multiplied it through by 3. But
yeah, if you want to multiply it through by 3, you can get what 3y equals x minus 31, and then bring everything over the same side. X minus 3y minus 31 equals 0. I can't type today, but you get the idea.
Oh, thank you, Dr. Gold. I think this is my favorite way to do it, to be honest, now that you've shown me this.
I'm learning as I go too.
Because it's like, it is a little bit like algebra intensive, but it's kind of direct what you're supposed to do, so.
Yeah, I think the idea of getting the bisector figured out is probably a pretty clean way to do that. And then just inverting getting the perpendicular from negative 3 turns into a 1/3 for the perpendicular, and then solving for b. Because any slope, anything 1/3 with a slope of 1/3 is going to be a as we move this around or whatever, that slope.
No, it's the mean value theorem. That's not nice. It has mean right there in it.
Cool. That's all I got.
Awesome. Well, thank you.
Don't know if that helps the person that asked the question originally.
I feel like they probably dipped from chat, but maybe they'll check the VOD. Or Menashe, if you're still here, please let us know, and I can try to explain it from scratch, so that way we're not like leaving you behind.
I can give you a screenshot of this math.
Oh,
if you
yeah.
want it on your Discord.
Thank you.
Yep. If I can get it to zoom out enough that you can get the whole thing on the screen. I'll put it in the Discord. Matt, is that math homework? Was that one of the questions, or?
No,
just
it
a
didn't
random
post in the
question?
Discord. You just put in math discussion, I
Math
guess.
discussion. Okay. Boop, boop. I'll put the graph up there as well
Oh, sure.
for fun.
Yeah.
Enjoy.
Awesome. Well, thanks for the help.
Thanks for letting me share.
I know any excuse to go into GeoGebra, right?
GeoGebra is king. Hey, I'm using science and technology.
There you go. Yeah. Perfect.
All right, catch you.
All right, see you. Okay. Always nice to have the guest star from Jed. Okay. It's kind of a neat problem once we know the technique. This is a good find. You're done with that. We're done with that. Nimatu was wrong. It's not easy to get you to admit that you were wrong. Oh my god. It doesn't. Oh, please tell me this is an answer. This one comment. It's okay. Good. It's an answer. No more geometry. I seriously need to figure out why my lap mic doesn't work in Discord. It's so annoying. I've Googled it and there's like nothing that I can find, and my Discord settings don't seem to have anything that would conflict. But grade 10 proof. It had 2 comments, so I skipped over. Oh yeah, Gamma Raybers got it. I'll show you the question, but if Gamma Ray commented, I'm not gonna have anything to add probably. Okay. But no worries, because there's already an answer, so I'm not going to post anything in this. So if you're just doing it, it's just going to be for fun. Hmm. Let's go to a different subreddit. There's some real analysis that I could potentially study too. So there's a couple ones from last week that I kind of didn't complete that I'd like to get back to. If I don't quickly... Minecraft algebra? Alright, what are they asking? How many blocks can a cube hold? Not counting... You do 5 times 5 times 5 if it's... So it's like a 5 by 5 by 5 block, or cube, or whatever, can hold 5 times 5 times 5 blocks, can it not? Wait, am I bad at math? 27? No, it's not 27. Well, unless I'm misunderstanding what they're asking about. Oh, internal volume. Okay, in that case, yeah, you do need to chop one off from each end, which is like 5 by 5 by 5 would turn into 3 by 3 by 3. Okay. The way, evidence. I just saw Minecraft algebra and I was curious what they were asking. See what the difficult integral is? E to the x over 1 plus x squared. If you do u equals e to the x and dv equals 1 over 1 plus x squared, you end up with having to integrate e to the x times arctan x, and who the heck knows what that is, I guess. But you could integrate that by parts again, and you'll do the, or maybe not. Oh, maybe the thing that I was thinking isn't right. Okay, never mind. Oops. Stop shaking my camera. Let's go do some real analysis studying, shall we? I'm gonna look at some of the ones from last week, though. Apparently, it is exactly with the real analysis questions from today. So I'm kind of gonna wait for. Why are you up there? For section 2 to happen tonight and see how it changes. But last week should be fine. So this one that I'm looking at here is today. I'm not gonna. I mean, I could look at these, but I want to look at last time because I definitely left some behind here. Was it here? I honestly forgot like everything that was on the sheet. I feel like it feels very unfamiliar to me. All right. So, oh, you know, I was working on 2, and I think I realized after I ended the stream that I made a stupid mistake. Hey, VOD, so this is referring to a Darboux interval or sum, which was a new concept for me, but it's very similar to a Riemann sum, but instead of doing a left, right hand, or midpoint, you do the maximum or the minimum in each sub-interval. So in upper Darboux sum, you take the maximum function value in each sub-interval. For a lower Darboux sum with the bar on the bottom, you do the minimum on each sub-interval. And since I see that you're new here, I'm studying... since there's no questions from chat, I'm just doing some like studying of real analysis for a class that e to the 2i pi is teaching live on Twitch. This is actually the second to last week of it, so this problem set that I'm going back and like looking back through is like pretty far on in the class. But yeah, that's what the bars mean. It's basically the Riemann definition of an integral, taking the partition, or you know, we've been calling it the mesh, but like the biggest interval and making it approach 0. Haven't seen much real analysis. Yeah, me neither. It's my first time ever studying real analysis. I don't know if this is like commonly taught in every real analysis class or anything, but we've been using it as we've just kind of been getting into integrals. Yeah, welcome in, by the way. So, oh yeah, so I need to, let me look back. I need to go to one of the class notes from very early on, because I realized that I made a dumb mistake in forgetting what a supremum and infimum actually mean. Because with this question, oh wait, I'm not even showing it. With this question 2 with the equation for lines, I was worried about our value for m, whether it's positive or negative, and that affecting your infimum and supremum, but I believe they actually only care about the absolute value. So you don't actually need to worry about positive or negative m's. All right, I finally did find the problem set, but that just says least upper bound, and bound does only care about the absolute value. So, okay. Let's, I'm not going to bother showing that on stream. So yeah, how are we doing this? Should I bring up the notes from that class? I kind of want to bring up the notes from that class. Let me find them. 1 second. I didn't come prepared. Okay, so when we were working problem 1, we were doing the basic calculation, but we were given a value for m, and we were given bounds. And we basically have to generalize these calculations in a particular line. Like, I think from this line. Oh, shoot, this is too zoomed in, though. Oh god, stop scrolling so far. We have to generalize basically this calculation and this calculation for an arbitrary bounds and I guess this m is already arbitrary. Oh no, and for arbitrary m. So I wrote m here, but then I plugged in 1/3 when I actually did this. Okay, but where does this come from again? We just observed. So when we tried plugging actual values, we observed that you basically get the sum of integers times some fraction. So I think I wrote it maybe a bit more clearly down here, where when we're in between 1 and 4, I think with 12 subintervals, you get the sum of integers from 4 to 15 over 12. Man, I wish I could remember this more clearly. And yeah, this is for the lower Darboux sum, so that's when we start at 4 for our function values. We're taking the infimum, and we go up to 15, because on that last subinterval, it'll be at 15 over 12 with a slope of 1/3. Kind of coming back to me-ish. Like, did we actually find that? We just observed this pattern, right? We didn't actually prove that this would be a pattern. I mean, it makes sense with a linear function, though. Okay. And with the quadratic that's coming in the next one, we're going to get some squares. I guess let's start writing stuff down and see where I get stuck. My favorite math equation? That's a good question. The Gaussian integral is pretty cool. Integrating e to the negative x squared. I think from negative infinity to positive infinity, yeah. So like the proof of that is pretty fun, I think. Oops. Put a link in chat too. How about you, Jackson? Do you have one? right, get this geometry off my screen, off my whiteboard. To be fair, that was just algebra right there. Okay, let's do blue. So we can say the lower one. Are we doing alpha to beta? Yeah, alpha to beta mx. Have you seen the path integrals? We've seen an uncountably infinite number of Gaussian. I've heard of a path integral in general, like just a line integral. I'd never heard of an uncountably infinite number of Gaussian integrals, so I think you're referring to something that I'm not familiar with, Jackson. I'm sorry, Wadawi. Your colors are similar. So I don't know if you're talking about like a line integral in general, or if you're talking about like some specific kind. They're different? Okay. Well, let's take a quick second and Google it. So that has me curious. Over to this browser, why not? Integral. Fourier transform or Schrodinger's equations. Oh, yeah. Those are good choices. I don't remember what Schrodinger's equation actually looks like. I definitely have seen it. Oh, with wave functions? With the wave equation. Oh, yeah, I barely learned this. Description in quantum mechanics, function integrals. Oh, wait, look, that happens to, okay, these are both things in quantum mechanics. Schrödinger equation happens to be right there. Very much what you do in physics. Oh, cool. Yeah, I guess those are both pretty physicsy things to choose. A Wiener integral? Sorry. Is there a simpler explanation? It's probably Wiener or something, but God, dude, I see Wiener integral and I can't not laugh. Oh wait, sum over all paths, dude. I read Stephen Hawking's book, Brief History of Time or something, and he talks about this concept a lot. It's like Feynman or Feynman, however you pronounce it, proposed this, I think. Like the history of a particle or something. Wien's displacement? What? Tomorrow passes the path integral? Okay. I'm not gonna pretend to understand all this stuff, but it is cool. Weighted by the exponential of a term proportional to the ratio. So Average over all possible paths integrated by the exponential term. I guess that's where the Gaussian integral comes in somewhere. Functional integrals and field integrals. Okay, it's getting a little bit too complicated for me, but this is interesting stuff. I'd love to know more about it. Just a little bit too hard for me to like learn on a stream. Let me go back to this for now. Oops, take the cam down. All right, so if we want that, actually, oh, you know, I'm already stuck. Do we want to just, we could say the definition of a Darboux integral. A lower one. I'll fix the screen capture in a second. I think exact way to revise speed I equals 0 to n minus 1. Okay. You need to learn all that stuff. Oh yeah. No, I appreciate you bringing up that like related like concept. Because yeah, the Gaussian integral just comes to mind because I really like the technique that you use to solve it. With it feels so wrong, but like you can basically just like convert it into polar in a super funky way. And I love polar coordinates. I just think they're fun. So. So the delta x, for the sake of this question, I think we're taking our partitions as uniform. And delta x is b minus a over n minus 1 in this case, I guess. Well, no, it's still, we still have n many partitions, even if our indices go from 0 to n minus 1. So it's going to be beta minus alpha over n. And then we're going to have a summation here. We have to figure out our infimum. How do I solve this integral? I know, I'll square it so no one ever... Exactly. Not only will I square it, but I'll square it with a different name for the variable, and I'll just happen to force it to conveniently become polar. You know, it's just a letter, so let's just choose y, and oh look, r squared is x squared plus y squared. Who would have thunk? That's a part that feels so wrong to me, but like, I guess it works. Okay, so if we just have arbitrary line mx, if we want the infimum, we have to remember so infimum supremum, so I was getting wrong the last time. We only care about the absolute value, so even if you know we're integrating from a negative up to a positive or something, we don't have to worry that much about like, you know, where, oh, the infimum right here is on the left side, but then over here the infimum is also on the left side? Was I really worrying about this for nothing? I think maybe my formula wasn't quite working out, something like that. It's going to end up being... Do we have to... Maybe you do have to worry about the value for m. Because for positive m, you definitely want a left-handed Riemann sum. For negative m, you would want a right-handed Riemann sum is what it comes down to. So maybe I was right to worry about it. Well, I guess the weirder technique to solve an integral, why do we, you know, how do I solve this integral? I know, by deriving it, if you're Feynman. So I think I'm right to worry about negative values for m. Because here, when m is positive, the infimum is going to look like that. And then we're going to start from alpha and go up to beta, like just before beta, whatever delta x happens to be. But over here, it's going to be over here and like that. Okay. I mean, I guess this is okay. Like, it's a reason why we can't do two separate calculations here, and they should come out to be the same thing. So, how are we doing this summation, I guess? So, we want to take the distance between alpha and beta. And then we need to, or this is our scale, and we need to step through this range by splitting it up into equal partitions, which is I over n minus 1. And then we need to add alpha, so we have our starting points. Because when I equals 0, you just get 0 here. We need to multiply by the slope, though, don't we? Like, this needs the slope in particular, or is it the entire thing that needs a slope? Because this is our input, but yeah, the entire thing needs the slope. So that way it's the output. Because that's our delta x, and this should be the output. And I've hopefully calculated it so that it is going to be the infimum. Okay. So yeah, just think about the input for what we'd want for the infimum. This is the range. As you step through that range, you need I over n minus 1 to split it up into, like, you know, if you want 12 equal parts, then your first part is going to be 0 over 12, your next part will be 1 over 12, 2 over 12, like that. Then you add on your starting point, just so you're not starting from 0. You're like, if you're starting from -1, you subtract that -1 off to get your shift. Okay, I think I like this. It makes sense to me intuitively. Now we want to kind of distribute things out. Or at least we can keep the beta minus alpha together. We want to multiply in the m, though, for sure. Then we can split these up into two different sums. Okay. Now here, the sum only cares about I. Everything else in the sum is a coefficient, and you can kind of push that out. Ooh. We do have the brackets here because that has to get distributed if we split it up like this. But yeah, everything that's not I can kind of get pushed outside of the sum. So let's do that. We have m n minus 1 beta minus alpha equals 0 n minus 1 of I plus, and then that doesn't have I in it at all. So you're just summing m times alpha n many times. So you get m n alpha. This we have Gauss's formula for. Speaking of Gauss. It's, if we're going from 0 to n minus 1, how does the formula work in this case? I think Gauss's formula normally starts from 1. I guess 0 doesn't really change it. So it's really just a sum from 1 to n minus 1 equivalently. And the formula goes n plus 1 over 2 normally, so we're going to n minus 1. Then we have n minus 1, I think. If I'm doing my Gauss's formula right. Yeah, I think this is good. So let's distribute the beta minus alpha over n in ooh. To n minus 1. Plus all right, now we get a common denominator here. To make sure I'm not forgetting anything though, I think we're okay. To n minus 1. Probably could order this better, but it's all good. Oh, I could have just canceled the n minus 1 there. Oops. So it's, I guess we'll cancel out the n minus 1, we'll cancel out... Oh, we could cancel out the n's as well? Really? I guess we can. Yeah, we can. Okay, so cancel out the n, okay, let's just rewrite the entire last thing. Is the n supposed to go away completely? I feel like I had to have made an algebra mistake, right? Maybe not. I don't know. I guess we are getting this exactly. I don't know. For a line, it might be a nice enough case where we don't, we're okay with our n's completely canceling. So what are we left with? Factor out of beta minus alpha. Does that make sense? I have no clue, if I'm being honest. Could try plugging in some example values. I am a little bit uncomfortable that our ends went away completely. Is this supposed to be, is it n times n minus 1 or n times n plus 1 for the Gaussian integral? Explain the solution. Oh gosh, bio. I'm not sure. I'd have to Google that one, which I can. It's actually easy. Let me look at the formula first, see if I'm getting it right or wrong. Grab a sandwich? Okay. Just tell me the formula. N plus 1. No, so I did have it right. Going from I equals 0 to n minus 1, it's like going from I equals 1 to n minus 1 because adding 0 to your sum doesn't change your sum. Oh yeah, Baya, once you're back, I'm gonna have to ask you how that fraction is laid out. Oh. Hey, random dude off the internet. I'm doing good. How about you? Oh, and thank you for the follow. Okay, yeah, so we should be dependent on n here. I made a mistake. Let me go get some water. Which I might use the bathroom too. So I just I'm taking a quick break, but I'm just gonna be back in like 2 minutes. To use the bathroom and get some water, and then I'll be back. Okay. No, I wasn't kidnapped. I was just using the bathroom. Ran into the internet kind of good too. I decided to try to take a step in getting smarter by just sticking by the people also taking steps to get smarter. Oh, well, welcome in. My kind of shtick, I guess, is I will answer homework questions that people have. And if things are slow like they are now, and I don't have questions, then I just work on kind of random questions I can find on the internet or like study questions, which is what I'm doing right now. Looks like Bio has a question though that. So Bio, how does this fraction work? Is the root 3 on its own? Or no, I guess it's root 3 plus 1, all of it over 2. And if you're interested in math streamers in general, there's a whole list of them. So those are both unit circle values. Is there some kind of trick that we can use here? Get Don on his beard. Root 3 plus 1 over 2 to the power of 2010. That's tangent. No. By doing squared to the 1005. Yeah. Root 3 plus 1 all over 2 to the power of 2010. So you could definitely bring like the squared in and then square it. What happens from there is you still have to the power of 1005 to deal with. I assume you need to find some kind of pattern and make a formula for the nth power of that. You'll manage? Okay. Oh, I don't want to lose this work. I'll do it on the left side here. Root 3 plus 1 over 2, so 2010. So yeah, 2010 is equal to 2 times 1005, which is what Bio was saying. So you can write this equivalently as this squared, parentheses 1005, and just worry about the inside and squaring that fraction. So let's do that, I guess. Root 3 times root 3 is 3. Plus 2 root 3 plus 1 over 4 to the 1005. Combine like terms, cancel a 2. Oh, I see what you mean. All we ended up doing was increasing that 1 by 1. But that's for squaring it. We have an odd power. So we might want to plot a cube or something? I'm not sure. So we don't have any more. How can we deal with this now? how many times does 3 go into this? Like, would it be the worst thing in the world to calculate this? 115 times? I don't know what we do with 115 after that, but like doing that cubed isn't the worst thing. And then there's no way that's prime. I don't know what goes into it though. Probably a weird number like 17 or something. Not 17 in particular. 23? It's 23. That's, no, we can't do a 23. We're not. There's a 5 though, but then yeah, we're not doing a 23rd power. Wait, I think you fucked it up. Otherwise, thank you for the follow. 2 plus root 2 of 3. Wait, you shouldn't get an imaginary number here. That's squared. It's root 3 times root 3 is 3. 1 times root 3 is root 3. Multiply it by 2. 1 times 1 is 1. Square the 2 is 4. 1 plus 3 is 4, and then you have a 2 in common. No, I think I'm right so far. Bio. Oh wait, is the original problem with what? With I? Oh. Okay, then yeah, things are different. So that's not 1, that's I guess. Interesting. Is chat bugging out? For me, it's okay. You might need to refresh the page or something, I'm not sure. All right, so let's try squaring that. Becomes 2. So we actually get a cancellation. All the 2's go away. It's just I root 3. Oh. That's an easier problem. I mean, you're going to get a very big power of 3, I guess, but. So, so you have to do, for I to the power of 1005, you have to do 1005 mod 4. 4 goes into 1004, so this is mod 1 of I, so it's like I to the 1 is just I think? And that doesn't really simplify any more than that. I think that's kind of weird. It's working now? Oh, is the audio buggy? Is it the music? Oh, good. I'm glad that you're a fan of my work. So I clearly am Ed Sheeran. It's not I root 3. I'm pretty sure you get an I. Unless there's something else that's messed up with this, but you do I times root 3. Like, there's no way around that. Oh my god. I can't write, dude. Like, that's what you get when you FOIL it out. You have 2i root 3. Oh, I didn't square the denominator, did I? Yeah, my bad. That's a 4 on the bottom. I definitely messed that up. I think I didn't necessarily have to erase all that other stuff, though. It's just whatever I had over 2, basically. Well, the 2 also gets the power. Like that? So it's not as simple as I thought. Switch to polar coordinates. Oh, that's probably a much better call zone. What math is this? I don't know what you... I guess this is a complex variables problem. It's pretty... The manipulations are pretty, like, algebraic, though. Yeah, so bio, like, do you know polar form with, like, r e to the I theta? Like, that's what it's called in English, but, like, what am I writing? I keep putting I when I mean to say plus. So yeah, if you convert it into polar form with an exponent, you have r equals square root 2 squared plus 1/2 squared. 3/4 plus 1/4. Oh, of course, it's 1. The unit circle. Theta is arctan. That over that. Which is 1/2 is the y, so that's pi over 3. Pi over 6. Pi over 6. I was visualizing the right thing, but I called it the wrong angle. So yeah, you can say that this is equal to 1 is r, so e to the I times pi over 6. So if you want to do the power of that, you just do that to the power of 2005 or 2010. Trig form? Trig form works too. But in exponential form, I think it's even easier. So if you have root 3 over 2 plus 1/2 I to the 2010, you can say it's equal to e to the I pi over 6 to the 2010, which oh my god, Cruz, that scared me. I was like, what who just went, oh my. Hey, SVQ, never used trig? Yeah, I mean, for this, I definitely would just rather use exponential. So you have to do 2010 divided by 6, which I basically did that before, but I erased it. It was 115. No, it wasn't. That doesn't make sense. Okay, fine. It's still the old-fashioned way. 2010, not 1005. $335. Okay. So e to the I, 335 pi, and I'm sure that evaluates to something relatively simple. It's going to be, it's pi times an odd number which on the unit circle, it's going to be that right there. So it just evaluates to 1? Or, no, I'm sorry. That's even. Odd number times pi is over here. Is it -1? I gotta check that. Teacher did it without trig. I mean, do you know the exponential form? Because that's, I think, even easier to use. Teacher didn't do it that way, really. Okay, so I did do that final calculation right too. Okay, so I think I did it right, but I don't know. I don't know how you'd be set to do that without doing the exponential form or the trig form. Oh, and just last week, myself and NoPro Bob had a competition for the best beard on Twitch, and unfortunately for me, NoPro Bob won, so I had to change my tag to second best beard on Twitch. He's now the first best. And hey, limit tends to infinity. So please explain Collette's conjecture. I don't know the Collette's conjecture well enough to explain it. I'm sorry about that. I know a lot of people are enthusiastic about it, but I know nearly nothing about it. Teacher got 502. 502 doesn't go into 2010. Oh, wait, times 1. Oh, wait, I see. I didn't read the second part of that what it was being multiplied by. Really? Oh, because it's the conjugate, maybe. Well, I don't understand the 502 power, how they evaluated that. It's how you evaluate that without exponential form. Yeah, but I'm really not sure how you do it without exponential form. I'm trying to figure out a way that you could find some kind of pattern in -2 + 2 root plus 2 root 3i over 4 to the 5 over 2, or to the 502. But that seems like they used the trig form without... Oh, okay, otherwise. You scared me there. Jeez. I'm still not going to let the message go through because it has that other interpretation, but thank you for clarifying that. Yeah, that's an unfortunate abbreviation there, but yeah, I know what you mean. You're trying to keep the raccoons away. Some app itself is kind of, I mean, Wolfram Alpha will do it. It doesn't, I mean, we can see if it'll show the steps in some other way. Hindsight is 2020. I imagine Wolfram Alpha is going to do it the way that Zone Ranger suggested, though. Mathway it's getting you through Calc 1. They don't have a step-by-step solution. I never heard of Mathway, to be honest. Algebra problem solver. Oh, okay. Oh, it's by Chegg. Okay. Yeah, my default equation solver is Wolfram Alpha. You can, even though they tell you it does calculus too. Ooh, okay. Yeah, so Wolfram Alpha, it doesn't give you the steps, but it'll show you like the first step. So what you can do is like, even though it breaks on this one for some stupid reason, you can like, whatever the step 1 is, you just take it and plug it back into here, and then you do step-by-step solution again, and then you can see what the next step is. It doesn't always work, but that's a way that you can like cheese the paywall. So yeah, but I don't know what to tell you about this in terms of solving it with the technique that you say. It feels like your teacher just did the exponential thing and didn't show it. I don't know how else you do that. I might not be good enough with complex numbers. Maybe there's some trick that I'm missing, but I'm not sure. Oh, really? What does it say for applied quadratic equation, I guess? Green's theorem in vector calculus? Yeah, kinda. I'm a little bit shaky on it, but I can always go over my favorite calculus website. It has to do with being able to convert a, what's it called? That's not the right section. Noob. Welcome in. Thank you for the follow. I tried with your name and then I tapped out. So yeah, Green's theorem has to do with converting, what is it, a line integral into a normal like double integral. And to be honest, I wish that I was more familiar with things. I think the problems are super fun. But this is my favorite site for all things calculus. Hello, noob. In Linux physics, that rolls off the tongue nicely. Surfy integral to curly integral to volley integral, basically. So, yeah, Green's theorem basically lets you, if you have kind of a mean-looking line integral where with this triangle you'd have to do 3 separate integrals to capture all 3 sides of the triangle, you could instead just figure out a function that represents the area and convert it into that double integral. That's kind of like the idea of why Green's theorem is helpful. If I love vector calculus, but I'm a little bit like out of practice on it, which is why I'm not getting that specific. But I'd recommend you just look at that site because it'll explain it much better than I can. Do you want to help me with some homework? Oh yeah, sure. Feel free to post it right there in chat or over in the Discord. Okay. Anyway, I shouldn't get too distracted just reading about Green's theorem because I could spend a lot of time just like going over this. Let me know once you've posted it. Otherwise, unless you put it in chat, and then I'll see it for sure. Oh yeah, we can definitely do that. Looks like we're going to be using the quotient rule. So I'm going to try and keep my work on the right there because I want to keep working on that. Basically, Stokes theorem of disguise. Oh yeah, I do know that Stokes theorem is like the generalized, like, n-dimensional version, right? SPQ. I think my multivariable class, if we did get that far, we only like barely covered it. So, I'm not that good with Stokes. I'm not that good with Green either, but I used to be good with Green. Back in the day. Okay. So otherwise, you have y equals just the trig that trips you up? Yeah, no, I feel that. 4 cosine x. Over 1 plus sine x. Back in the yield, dy dx, yep. Okay, so now unfortunately this is going to be a quotient rule. Quotient rule is a pain, and I like to look for some kind of identity or something that lets me avoid it. But I don't see a convenient trig identity to use here that gets rid of the fraction, so we just have to kind of suck it up and do quotient rule. So I always remember quotient rule as you derive the numerator first. So the derivative of 4 cosine x is going to be minus 4 sine x times the denominator as it is, minus, now you keep the numerator as it is, times the derivative of the denominator, which 1 plus sine x derives to just cosine x, over the original denominator squared. So I might have gone too fast. I wouldn't blame you if I did. But if it helps, I'll kind of separately write out the derivatives up here. For cosine x derives to minus 4 sine x. And then that denominator derives to just cosine x. So then that one went over there. That one snuck in right there. So are you with me with, there's some more simplifications we have to do, but are you with me so far? U equals 1 plus sine x, so du equals cosine x dx. Now it's just algebra? Okay, yeah. So I'm glad that you're with me here. I think that sub thing probably works. I don't usually think to use subs with derivatives, but yeah, there's no reason that you can't. Probably let's save you some work here, if you're good with them. So yeah, let's just read out that 4 sine x. I definitely see an identity that we're going to get here. So we get minus 4 sine x minus 4 sine squared x minus 4 cosine squared x over, keep that 1 plus sine x squared as is. Now the identity that I'm seeing here is we have a sine squared and a cosine squared. Their coefficients are the same, so we can use Pythagorean or the Pythagoras identity here. I'll even factor out, I'll do one extra step to hopefully make it even clearer what's happening. I'm going to factor out the -4 from those. So you factor out the -4 from there and there, you get sine squared x plus cosine squared x. And sine squared plus cosine squared is just 1. So we get -4 sine x minus 4 over 1 plus sine x squared minus 4. Now there's actually another thing that we can do here. We factor out the -4 again. Sine x plus 1, 1 plus sine x squared, basically the same thing. We can get a cancellation here. That's going to cancel with that. So I'd say that our final answer, as far as we can go, is -4 over 1 plus sine x. Kind of deceivingly simple, to be honest. Integrating that would be annoying. So let me know if I... High D, low... Okay, I think it's backwards, but yeah, that's really common mnemonic or whatever it's called to remember the quotient rule. Yeah, no problem. Otherwise, thank you for the question. Let me just verify the answer as well, because I never want to give someone bad advice. I'm pretty sure I did everything right, but it would be the first time that I made a mistake. Grab the negative from the derivative cosine. Oh yeah, that'll mess the entire thing up. Wow, Wolfram Alpha doesn't even simplify it, dude? Come on. It's getting lazy on me. Here we go. Yeah. And bio, when looking for f min or max, do we always get the same result doing with derivatives and with minus b over 2a? The minus b over 2a thing is for parabolas, I think. Only. The derivative way works for any function. Minus b over 2a is only for parabolas, though. But it does work for parabolas, just finding their vertex is always going to be the minimum or the maximum. Yeah, shoot. Otherwise. Hey, Epson, those are deep gulps. Sorry, it probably sounds worse because I use a lap mic, but I'm also a thirsty boy. I'm a known water enjoyer. Let me go erase the board while we oh, okay. I gotta derive arc cosine? You consider yourself addicted to water? Whoa, okay, what's happening there? 15 to, okay, root 15 times t. Add mukbang to the title of your excuse. That's the, that's like a type of Korean food, right? I forgot what exactly it means. Brother was thirsty. So like, oh my god, when I first wake up, I'm so freaking like thirsty. It's crazy. Yeah, you should hear me then. dy dt. Oh, okay, yeah, that's a better way of phrasing it. I don't have this memorized. I think it's minus 1 over 1. Let me just Google it. Inverse trig derivatives. So actually, there's a way some classes make you show this. Others just teach the result to you. So if you're allowed to just use the formula, drinking too much gives about use to drinking a lot. That might be true. All right, so otherwise, were you taught like this end result for the formula? Or do you have to actually like go and do some math beforehand with taking the cosine of each side? Or if you weren't taught either way, I'll probably just show the formula way, because that's the way that I learned it at least. He wasn't taught at all? Oh, okay. Then maybe I'll show you the not formula way. That might be a better way of doing it. Because actually, I only just learned this literally like last night from Dan's stream. Yeah. So, yeah, and Linux Fit Physics is saying that, or like how I'll do, which I didn't actually know was how you showed it, but let's go through and work through it. Well, there is one part that might be a little bit difficult to wrap your head around, so. Or it's kind of hard when you first see it, but you can get used to it. So we'll still go through it, but if you don't get one part, then I just recommend remembering the formula. So we have what, root 15t, I think? You don't know what arc cosine is? Oh, yes, it's inverse cosine. Okay, yeah, root 15 times t. So yes, arc cosine and inverse cosine are the exact same. I personally hate this notation because the to the power of -1 could get mixed up with 1 over cosine, and it's just a messy mess. It's a messy mess. So I like arc cosine. It is the same thing as cosine or inverse cosine, but inverse cosine is different from cosine to the power of -1. So that's why things get tricky. That's why arc cosine exists, that notation, but they are the same thing. But it's the same exact concept where like if cosine looks like that between would it be minus pi over 2 and pi over 2, then arc cosine is reflected around the line y equals x. Does it look like that? Yeah, I think it looks like that at least. But it's the same like reflection thing that you learn with any inverse function. I might not be graphing it right because I'm not smart, but it's just an inverse cosine. So the idea for finding the derivative of it is you either memorize the formula, inverse secant. You can either memorize the formula for the derivative of arc cosine, or you can solve it for t or whatever your independent variable is and use a trick. I'll show the way that's not just memorizing a formula. So let's try and isolate t and get it in terms of y, because we don't know the derivative of arc cosine unless we know the formula, but we do know the derivative of cosine. So if let's take the cosine of each side. Cosine of arc cosine, that's a function of an inverse function, so they undo each other. So if you say the cosine of arc cosine of root 15t is really just root 15t. anytime you have a function of its inverse, they basically cancel each other. It's not technically like a cancellation, but it's a cancellation. Now to isolate t, we just have to divide each side by root 15. So 1 over root 15 cosine y equals t. Cosine to the -1 of x equals r cosine, and cosine x to the -1. Yeah, SBQ, I do like that. Yeah, I mean, I think I like arcs even more still, but that should be the convention. I don't know if it is. I hope it is. Gotta do the chain rule. It's not necessarily, okay. If you did it the formula way directly, there'd be a chain rule. Here, it's going to be a little bit different. Kind of sidestepping the chain rule, I guess. But when we have the equation rewritten like this, we're not getting dy dt, we're now getting dt dy. And that's okay. We have to do one other step. So what I'm going to do is I'm going to take dt dy of each side. This is the same exact thing as when you just take the derivative, like we can treat this the exact same, even though the variables are reversed, we can treat it the exact same as normal, taking the derivative. So cosine derives to negative sign, the coefficient stays the same, and we're going to get -1 over root 15 sine y. We derive it like it's any other normal function. dy by dt of t is just dt dy. And I'm doing it this way because there's actually an identity which is dy dt equals 1 over dt dy. This is one of those weird, actually, let me say the point of this. The point is that we're now just going to flip this, and that's our answer, almost. We have another step or two to do after that, but we can basically flip each side of the equation here. It's one of those weird things where dt over dy, it's not technically a fraction, but for a lot of purposes, it behaves like a fraction, even though it's not technically a fraction. It's one of those weird things. Oh wait, limit tends to infinity. Let 1 be a cube root of unity to the minimum of the set. Limit tends to infinity. I'm not sure I'll be able to answer that question. I'll probably go to the Twitch chat if someone's interested, but I haven't done a question quite like that before with roots of unity. It's probably not that bad if I knew the technique, but I don't know the technique offhand. Okay, so this way is kind of weird to do until you actually see it. So let's use this identity and basically flip each side. What am I doing? Equals dy dt. So technically we found dy dt, but it's in terms of y still. We want it to be in terms of t, because that's what they're expecting to give you back as the answer. So we do know that this y is equal to arc cosine of root 15t, and that's how we get things back to be in terms of t. I'm going to bring that root 15 up to the top as well, because it's 1 over root 15. Sine, now y we know is arc cosine. dy dt. So technically we have the answer, but sine of arc cosine is kind of ugly. And you can actually simplify that by drawing a right triangle. And now that I actually see this right now, I can show you just the formula way if you know the end result too, because this is kind of a lot. But arc cosine of anything is just an angle, and we can take sine of that angle. We know that cosine is adjacent over hypotenuse. So that means adjacent is going to be root 15t, and hypotenuse is 1. So draw a right triangle here. This is kind of the thing that is really weird when you first see it. It's still weird to me now, even though I've seen it a bunch of times. But we have sine of arc cosine. This is how you simplify it. Let's call that our angle. Now we need to take the sine of this triangle at the same angle. So we need to get opposite into over hypotenuse. The opposite we can find with the Pythagorean theorem. Root 1 minus that, 15t squared. Okay, so we know that sine of this triangle is this over that, and over 1 is just the same thing. So what we get is dy over dt equals minus root 15 over, now this entire thing is equal to that. So you could call that your answer. You could put it all under one big square root if you cared to. Is there a different simplification you could do? Yeah, you could, but it doesn't really make it look much different. So yeah, like one of those is your answer, or you could like factor 15 out from the bottom and cancel it, but then it's kind of all the same. So if I lost you, I definitely wouldn't blame you. Oh, did you switch accounts? Now you're must be otherwise, or did you change your name? That makes sense? Okay. Oh, I guess you could remember that as an identity. Linux physics. When it comes to VC1 with your phone. Oh, okay. Fair enough. Forgot your password? Okay. So yeah, the complete other way that you could do this is just by memorizing that d dt of arc cosine t is minus 1 over root 1 minus t squared, I believe. That's what the formula was? Yes. And the only difference here and here is the root 15, so you do a chain rule. So if you can't be bothered to memorize this formula, then this way in black is how you do it. But if you do memorize the formula, you don't want to do all this work, then this isn't too bad either. So first doing the derivative of arc cosine. We get 1 minus, now it's root 15t instead of just t, so 15t squared. Then chain rule, multiply it by root 15. And this will come out to be the exact same thing as here. So, you know, like 10 lines or 3 lines, depending on how much memorization you like to do. So I hope that makes sense. Also switch sine to square root 1 minus cosine squared. You could. I don't know if that helps you. Yeah, PhD, that's definitely true. For the first way, it's a generally applicable technique. So it's good to be aware of it. And I actually wasn't aware of it until literally like yesterday. So the bottom instead of using the triangle, Really? That works? Oh, yeah, that's sneaky. I like that, Bladwy. So you can figure out, okay, sounds good otherwise. Oh wait, but you have cosine squared of arc cosine. That doesn't cancel the same. Well, does it? Yeah, it does, maybe. Yeah, because you bring the squared outside. No, yeah, you're right. Why do we? Oh, ooh, shoot, I missed some things in chat. Hello to you. Sorry that I missed you. Too many T in those expressions. That's dt, dy. Oh, shoot. Yeah, I messed up my notation. You're right. Too many T's. I'll fix that in a second. And noob, oh man, I'm too late, but thanks for being here. If you do still happen to hear this, I appreciate you. Yeah, it's you take the d by dy of each side. Oops. Yeah, you take the d by dy of each side, and that gets you the dt dy. Okay, I'll get my notation mixed up a bit there. Yeah, okay, so something about that felt off as I was explaining it, and it's kind of like glazed over it, so thank you for pointing that out. And you know what? That is a save, for sure. Saves at Linux Physics. So, and actually, since we've had a few new faces around in chat, so let me just do a general shout out to other math streamers for those who are interested. Yeah, and we do a little thing where like when you make a good save on a problem, or like you point something good out, which actually I should give out a few more because we've had some good shouts in chat. We call it a save, and just for fun we keep track of it. Bladwy has had some good ideas. Peach Tea has had some good ideas. And yeah. That emote is terrifying. Okay. Oh, that's a nice emote, PhD. Dude, PhD, you always have a relevant emote. I love it. Okay, so I don't see anyone else asking a question in chat. So I was working on that real analysis stuff, wasn't I? Oh, that's right. The stuff I have on the board in blue. I made a mistake somewhere. Let me erase the left half of the board and see if I can spot where I made the mistake. So like, I was doing the lower Darbosum for a line. I made the simulation that m is greater than 0 because I think that changes things. But somewhere along the lines of my calculations, the ends cancel it out completely, and I don't think they're supposed to. Trying to figure out where it went wrong. Okay, so Should that be n minus 1 or n minus 2? I think it's n minus 2, and that's where our cancellation, that prevents the cancellation. Thinking about it. No. Actually, no, I don't think it does. Or does it? Yeah, no, I feel like it should be n minus 2. Or maybe our indexes are wrong. This is getting both the starting point and the end point. We want only the starting point for the lower Darbosum. You love getting gifted subs from random channels because then you find ways to use the emotes. The n minus 1 will take away 2 points. So let me get the problem back up on the board. So that's the ultimate goal. This one equation will cut off the last ends. That's kind of a weird thing. So I let me I guess like back up. So because I'm in section 1, I got the section 1 worksheet, and this is the definition we were given, but I think Zach revised it to n minus 1 for the upper limit here, is my recollection for section 2. And so I was kind of blindly just making it n minus 1 as well and trying to engineer everything else to follow that. Root 3 plus I to the 2010 in trig form. I'm gonna have to work that out. We can do that though. Cut off the last ends. So it's still I many sub intervals. That's just the actual indexing that I'm getting caught up on, I guess. I think it's supposed to be n minus 2. Because if you go all the way... Well, no. I is going to n minus 1 still. I don't know. Okay, let me work on Bio's question, and then I'll think about it more. N minus 1 minus 1? Yeah. It's something like that, PhD. Or like, maybe we change the summation even. I don't know. So Bio, you have root 3 plus I to the 2010? In trig form. Okay. Well, let's get an exponential form first, because trig form follows from the exponential form. We expect to get 1. No, we don't. They have to be over 2. Okay. It's going to be root 3 squared. I should write that out. It's 1 squared. That's 3 plus 1 is 4. Square root of that is 2. Beta is equal to arctan that coefficient 1 over root 3. Arctan of 1 over root 3. That is pi over 6 again, I think. Yeah. Because it's the same number as last time, just scaled differently. That one was over 2, this one is over 1. So we get the same angle. That makes sense. Just a radius of 2 now. Okay. So now we're ready to put it into exponential form that we know r and theta. So r is 2, so we get 2 times e to the I times theta pi over 6 to the 2010. Let me come down there. So basically the same math, 2e to the I, 2010 over 6. What did I say that was? 335? 335 sounds right. I think it's 330. Yeah. 335 pi And then now to put it into trig form, 2 stays outside. E to the I 335 pi is Euler's identity. So it's cosine of our angle plus I sine of our angle. And that's your answer for trig form. Wait. 2 to the 2010. There we go. Now it's right. It's not 1, so it's I, so it's root 2, right? The number in front of I, yeah. Because, case Petri. Yeah, the number in front of I is what's important. In this case, the number in front of I is just 1, so that's what we use for our calculations. Yeah, cosine of 335 pi. That's -1, that's 0. To get -2 to the 2010. But that's not, I mean, you could call that trig form too if you already evaluate it, but normally as for trig form, they like want something like that. It's just all the problem from before? Yep, except for the over root 2 part. Or the over 2 part. So slightly different problem, but the same exact work, basically. Oh, that's what you're, yeah. Can we pause the first stream for a bit? I have a busy week. You don't want to catch anyone to catch up. Oh, yeah. All right. No one's allowed to be first except for Spetri. Okay, so yeah, I'm still trying to figure out my indexing. What's R of 3 minus I? Or root 3 minus I? No, it's the same thing. The sign of it doesn't actually affect the radius. It's the same exact formula. It's 3 squared plus -1 in parentheses squared, which still comes out to be 2. So yeah. But n equals 4 and draw 3 boxes? Where are you going with that, Linux physics? New category? Yeah, Viv, I figured I'd try out science and technology to see if we get any new faces coming through. I know I'm gonna like stick with it or not, but I figured it's worth a try because I never seen this category before. Who has the best beard on Twitch? It's No Pro Bob. We had a beard off competition last week and he won. So I changed the tag on my stream. Dual sine and cosine just input something. Consider it treason, the trig form. Well, you can consider X and Y or A and B. It's kind of a matter of preference. So yeah, well, I think what your teacher did. Oh my God, Cord, behave yourself. It seems like your teacher. I mean, it seems like your teacher split it up into two separate problems. Root 3 plus I to the 2010 over 2 to the 2010, which is completely fine. And the teacher did this work up here for that top piece, and just remembered the bottom piece at the very end. So answer your question with A's and B's or X's and Y's. I mean, I don't think there's a substantial difference. Normally they use A and B for complex numbers from what I've seen. There's no reason you couldn't call them X and Y though. As far as I know. They're just letters. I didn't understand your question. It matters since if it's minus I, Y is still 1, but B will be -1. Oh, I wasn't taught that distinction. Why would Y be +1? Well, if you're talking about like when calculating the radius, it's always the square root of the first number squared plus the other number squared. So if it's negative, it doesn't even matter. It becomes positive. Now the negative value would change your angle. It would change that arctan calculation, for sure. The radius is the same though. I can draw this out. What number do you put in n over 2? Is n the one in front of I, or is it the one under the root? Are you talking about de Moivre's formula? Because n is just the power in de Moivre's, unless I'm misunderstanding you even more. It's like, if you have a complex number to a power, you just multiply it by the angle straight up. So if you have 2010, you do 2010 times whatever angle you calculated, which we got pi/6. If you had a minus I, that angle would definitely change. Cosine of fi equals n over 2, and sine, I don't know what fi is. Ugh. Well, I don't know what it's. I don't know what you're talking about with this bio, I guess. Okay, so, okay, it's phi. Okay. Why is it n over 2? I don't know what n is here either. Talking about when putting it in trig form. So, okay, this is working out what the angle would be. What's a simple way to explain this? So, so the reason it's divided by 2 is because the radius is 2. But we want to have it in unit circle values so we can actually get an answer for the angle. I don't think we need this anymore. It's the bottom part. Okay, so so if you have 3 minus I, well, let me not do parentheses. That's where 3 minus I is on the axes, I guess. So the distance from, we want to figure out basically our unit circle angle, because that's what we need for exponential form. We need to figure out what theta is. The issue is that 3 minus I has a radius of 2. The unit circle has radius 1. So if you want to use the unit circle here, we have to basically scale it. I'm not sure if there's a better word for that, but oops, sorry, it's root 3, not 3. That's why it looked wrong. What the fuck is n? What number? I'm getting there. Actually, well, I mean, it's the way the question is phrased is a little bit weird. But I mean, okay, how about this? If I drew the point wrong as well. Just like put it there. Just make your right triangle. If all I care about is the n, cosine is the x component, which is root 3. Because just the x component. And then sine is the y component. So this is where you're asking if it turns to positive 1. I want to call it -1. You might, I mean, it kind of depends on you can do either way. You can keep it as positive or negative as long as you remember you're in the fourth quadrant. That's the important part. So you can make it positive or negative as much as you want. Just remember that you're in the fourth quadrant, basically. Then take it as positive half. Just, you need to be very sure that when you do things with these numbers, that whatever angle you say phi is in the fourth quadrant. You should get the same answer either way. But if you do this with positive half, you're going to get like that angle there. So just remember to add, you gotta go around the unit circle 3 pi over 2 times. So whatever angle you get from this, add 3 pi over 2 to it, basically. That'll get you into the fourth quadrant. It's not the same because you look for the angle they both have. Well, no, you have to compensate. You don't get the exact same thing, but you can do it either way. You just have to know what your angle that you found corresponds to and then compensate for it after. Like you have to like fix it, whatever you get. So even though you might get a different looking angle, you have to like adjust it still. Multiply the angle by -1? Well, I mean, that works too, I guess, flatly, but I think I'm trying to get it between 0 and 2 pi. If you add, I think it works. So what we want is this 11 pi over 6 angle. If you just make the sign positive for fun, which you can do, you get this pi over 6. So what's pi over 6 plus 2 pi over 3? No, we're adding, oops, I wrote it wrong. We're adding to the angle, not to the actual point. Wait. That's not right. Add pi. Oh. Okay, so 3 pi over 2 isn't exactly right. Yeah, I was being a little lazy with my unit circling. I got to this angle. You need to do another. Okay. If you want to get it, so maybe what we said is better just dealing with the negative angle. If you you could do negative pi over 6, and then yeah, do 2 pi minus that. Then you get the proper angle, and it's much less thinking. Thank you for that. And I was misinterpreting what you were saying before, too, with on the x-axis and the y-axis. Imagine a point on the x-axis. Adding 3 pi over 2 doesn't keep you on the x-axis, puts you on the y-axis. Right. I thought that's what we needed, I guess. I was just visualizing it wrong. Multiplying is just looking for the angle. Bio, I think if you play fast and loose with the signs like that, you can potentially get a wrong answer. I think. I'm trying to work out. The implications of what you're saying. So if you multiplied by positive pi over 6 instead of negative pi over 6, well, I guess that one would work out the same. Would it? In this case, it would. Maybe you are right, Bio. I'm trying to figure out if that's a coincidence or not. It might not be a coincidence, though. You might be able to do that in general. I just feel like it's dangerous. I'm not sure though. I'm getting a little like mentally tired for myself here too. I don't have the excuse of it being like nearly 2 in the morning. Yeah, I might wrap the stream up and raid out in a minute here, unless someone has another question for me. I'm still thinking about this Darboux sum. Maybe I should look at the work that we did the day of. I'm just gonna take like a minute or two to look at this, and then if no one else puts a question in chat or like a homework help question or something, I'll wrap things up. Equals 1 to n. This was for the upper sum. See, I feel like we do need to adjust the limits of the sum maybe to be n minus 2, and then things work out okay. Hopefully. Because we played around with the indices here. Well, I mean, I did. I forgot that it was supposed to be I equals 0 with the definition we were given, but it happened to work out okay. See, with my existing work, I just make it n minus 2 and then things work out. Let me, okay, let's quick, because now it's going to bother me. Wait, is that n minus 1 or it's going from... Yeah, it's n minus 1, because we start at 0, and here the 0 does matter. That gets adjusted. Gauss's sum gets adjusted. So now things don't cancel quite the way they did before, and that's actually how it's supposed to be. M beta minus alpha squared. I swear one day I'll get through this entire problem. It's just a lot of algebra to work through, so it's hard to get it done in one stream, I guess. I might have to do this one off stream to be honest, if I want to actually get through it. Get a common denominator, factor out an m of beta minus alpha. So probably multiply that out on the inside and get some kind of nice cancellation. Let's do that. See it through to the end here. Do we get a nice cancellation? Plus 2 alpha, minus 2 alpha? Okay, yeah, we'll get a cancellation. It's worth it. Beta minus alpha. Okay, beta n minus alpha beta. Wait, no. Minus 2 beta minus alpha n. Getting myself enough room. Plus 2n, or no, plus 2 alpha. Don't close those parentheses. Plus 2n alpha minus 2 alpha. Over 2n. And then, oh, those don't cancel. Did I write this wrong? Wait, oh yeah, those two cancel. Then alpha n, beta minus alpha. Beta n, 2 beta are just those. Minus alpha n. So we get, okay, beta n minus 2 beta plus alpha n. Those two go away entirely. Does that clean up in any other way? It looks kind of ugly. It's what we get though. I guess that's what I get. I'm gonna take a screenshot of that and save it to my computer. Oh, hey, Zach. Oh, shoot. I missed someone on YouTube. Sahil Dusk. Sir, can you please help me with 15 to the 4? Never mind. Oh, okay. Yeah, it's the first thing that you said. 15 times 15 times 15. But if you got your answer, then... glad you got it. Shoot. Zach said 5n plus 1 over 2n. I could plug in the example calculation that we did and see if the answer matches. Like if we have m equals a third and we go from 1 to 4. Actually, we don't even, yeah. We can leave the ends there. Oh wait, actually, is this, no, it might be Mode's math, but I'm not gonna do it. 1/3, beta minus alpha is 3, beta n, beta is 4, minus 8, because 2 beta, plus alpha n, alpha is 1, so just n, over 2n. So that's 5n minus 8. I did another thing wrong. Wait, this is for okay, this is for the upper. Oops, I think the lower is just 1. Or, oh my God, do we not do we didn't do the lower. So like, it's just repeating the calculation. Oh God, I should have done it for the upper so I could verify it. Dang it. It's just a mess of Greek letters. Trying to see if I can quickly spot where I went wrong here. Somewhere on that right side. Hey, Zach. So no, my answer is slightly wrong, I think. I tried plugging 1 and 4 and comparing it with the calculation we did in class, and it's a little bit off. I might just leave it and come back to it another time, but it's annoying that I'm so close, but just like a little bit wrong. I also don't know exactly what the right answer is because in class we only did the upper sum, and for this one I did the lower sum for some reason. But I don't think it felt wrong to me. What did I? If you simplify what I got, it would be 5n minus 8 over 2n. Should be good to use n minus 1. Really? For the summation? So I originally had it as n minus 1 there, but I think that gets you both endpoints of the line, doesn't it? You have to stop like just before it. Because if you start from I equals 0, then you're starting just at alpha, which is fine for the lower sum. You have to stop like right before your beta. So that's why I did n minus 2 instead. And I did take your edit from section 2 because I think you made that n minus 1 in the definition of a Darboux sum. So I was trying to match that, but I did modify the upper bound to n minus 2 because of that. So I originally had it as n minus 1, but then all the n's canceled out. And that definitely wasn't right. Lower Darboux sum, yeah. So I'm not sure exactly. You think the 1 over n minus 1 should still be n? Oh. Like that one? Or like the I over n minus 1? Oh, I think you're right. Yeah. Because it's n many intervals. Yeah, okay, that makes sense. I was getting mixed up with the n minus 1, with which n minus 1 you were talking about, I guess. Just get rid of it from here. Yeah, that makes sense. I'm gonna wrap up the stream soon, but I'm so close to getting the answer here. I want to see this through. I think I fixed everything. Oh, that's not fixed, is it? So we get n squared there. Just unfortunate. Okay. That's annoying to multiply out. I hope I got that common denominator in my head. Yeah, oh, no m. Factor that m out. Oh, what's that? Mint White. Thank you for the follow. So we can take an n minus 1 out, make our lives a bit easier. Uh, beta n minus 2 beta minus alpha n plus 2 alpha plus 2 n alpha. Beta n minus 2 beta plus n alpha plus 2 alpha? That doesn't feel right either. I made another mistake somewhere? Should get something nicer than that, right? Does it group? No, it doesn't group. The sign is wrong. I don't know. I keep making an algebra error somewhere. Limit as n goes to infinity? Oh, just do the limit then? Oh, were we supposed to do that? I mean, I definitely can do that. Okay, so I mean, yeah, we can just do it, I guess. I was trying to get like the general formula with n, but if we're allowed to just do the limit as n goes to infinity, I guess maybe at this step we should do it. We're gonna have equal degrees on both of those fractions. of the above. I'm not going to rewrite it all. So n squared, n squared. The coefficient on top is m beta minus alpha squared over 2 plus n, take the leading coefficient, that's beta minus alpha, dude. That doesn't factor then. There's supposed to be 2m alpha, by the way. For me, that's just what we get. I don't know. You don't technically have to? Okay. Good to know. I don't know if that's right or not. Could try seeing if we get something reasonable if we do the numbers from class. B squared minus alpha squared? Really? B minus A times B plus A? Oh, I factored the M out and I didn't actually factor it out. That's my problem. There we go. Because that turns into, wait, yeah. Beta minus alpha times beta plus alpha. And if you multiply it back out, it's the difference of 2 squares. Okay. Frick. Okay. Finally got there. The fundamental theorem calculus works. That's good. I was in doubt. I don't think those dudes working on the fundamental theorem calculus really knew what they were doing, so it's good to verify. All right, so I'm kind of running out of brain power here. I'm glad at least, actually, let me, I need to get a screenshot of this work so I can refer back to it later. I do want to get through the problem set that I was just working on, but God, it's just so much algebra. Actually, if we're taking the limit as n goes to infinity, we should get the same result for the upper sum, right? Oops, not that. So maybe at this point I'll feel comfortable skipping over 2 if I know what the point is going to be. So if you do limit as n goes to infinity, then you expect the 2 integrals to equal each other. Let me save this to my computer. Oh, Linux Physics, thank you for the follow. Day 18, prompt to work lower. So maybe next time I work on this, I'll try the integral one, or the integral, the quadratic one. But anyway, let's see who's on. I think actual education is on. Yeah, I think we'll write out to actual education here. There's been a huge thanks to everyone who's been around here. Miss Algebra problems are good to develop intuition. Yeah, that's why I was trying and not just like, can I go like, oh, I get the point. At least for that one. I might hand wave the second part, or at least do it on my own time, but yeah, thanks so much everyone who's been around here. We're gonna react to Actual Education. Cool dude. He also does math help and physics, and I even saw him doing a chemistry problem. If you're gonna be around in less than 2 hours, like an hour and 50 minutes, there's gonna be the reanalysis class from E to 2 Pi, Zach, which I highly encourage you all to go watch. It's super cool. Thanks for being here, Zach, and for checking my work. I'll be back with some kind of game tomorrow, probably Daisy, and then my next math day. Oh shoot, I need to stop the YouTube stream. Bye YouTube.